Good morning, y'all. Welcome back. Let's get this semester off to a great start. We are starting a new unit today, but don't worry, we're going to ease you back into it. These first couple lessons are not super difficult, but we'll be getting into the unit called exponential functions, just the next type of function that we are going to be talking about. But today we're looking at graphing linear, a linear function, but linear inequalities. And we're going to be able to identify the solution point. So instead of graphing a linear function or equation where we just have a line, we're going to graph a linear inequality, which is where it's not y is equal to something, it's y is less than or greater than or less than or equal to or greater than or equal to. So in order to be able to complete this lesson, we're going to need to be able to identify if the inequality is in slope-intercept form, in that y equals mx plus b form. The only difference is that equal sign won't be an equal sign in an inequality. If not, we're going to need to rewrite it in slope-intercept form. From there, we need to identify the y-intercept, identify the slope, use it to get more points, sketch the appropriate boundary line. We're going to talk about two different kind of lines, and then identify where to shade, either above the line or below the line, and then be able to identify if a point or a solution, remember solution is a point, is in the solution set or in the shaded region. So let's go ahead and get started. The graphical solution to a linear inequality is in two variables, involves a boundary line and a shaded region. Now you might have heard me a second ago talking about the shaded region. It's either shading above or shading below. And a boundary line is either going to be a solid line or a straight line. So maybe you want to add that solid or dashed. And then the shading can either happen above or below that line. So let's take a look at the different inequalities that we can have and what that looks like. All of the inequalities we're going to look at are already in slope-intercept form, in that y equals mx plus b form. In order to graph an inequality, you have to have it in y equals mx plus b form, in that slope-intercept form. So let's look at this top one. We have y is greater than or equal to mx plus b. I wrote that in words, greater than or equal to. And if it's greater than or equal to, we're going to have a solid line because it's equal to y. It's not just y is greater than, it's y is greater than or equal to. So that line will be solid. The shading, because it says y is greater than, the shading is going to be above the line. Now, if we were to give a kind of brief illustration, I'm just going to draw a random line. So if I draw like that, then my shading would be above the line. I kind of use common sense here when I'm thinking about where is above. It's just look at the line, and if it looks above the line to you, it's probably right. Right? But it will differ depending on the direction of the line. So for example, if I had another line, but it was going this way, above the line would be over here. Okay, still looking above the line. Let's look at this next one. It says y is less than or equal to mx plus b. Okay, that's what that inequality symbol means. So same, because it's still equal to, it's still going to be a solid line, but this time the shading is going to happen below. So let's say we have that same line. Now that shading is going to happen below the line, but it's still a solid line. And then likewise, if we had a line with a negative slope, below would have just been on the kind of the left-hand side or the bottom side of that. Now we have two more inequalities. This next one is y is greater than mx plus b. And when we have greater than, it's not equal to, it's going to be a dashed line, not solid, because we're not including what's on the line. We're just going up to it. Think of it the same way when we were graphing domain and range, and we had using inequality symbols greater than or equal to or greater than, and we had those shaded circles. We either had a closed circle or an open circle. It's the same idea. This is basically an open line, so it's going to have spaces in it. And because it's greater than, the shading is going to be above. Oh, I didn't even change my color there. We'll keep it in purple for this one. So now I have that line. I could have the same exact line, but it's going to be dashed. And then the shading is going to be above. So it's still going to be anywhere greater than that line. It's just not going to include that boundary line. And then our very last one is y is less than mx plus b. Okay, and you might have guessed it. This is going to result in another dashed line because it's not equal to. And it's going to be shaded below. This means I have a lovely dashed line, and I need to shade below. Again, the same kind of thing as last time. I could have a dashed line if it's going the opposite direction. Right? Shading below is still whatever you think of when you think of below. Okay, I have a lot of extra room in my thing, but I know you guys don't as much. I'm not sure why mine copied like that. But hopefully this gives you a little bit of an idea. Okay, this chart is going to be super, super helpful for you in knowing what kind of boundary line and shaded region to draw. Okay, those are the only two things different from an equation to an inequality in graphing them. You might have to have a dashed line, and then you're going to shade after you draw that line. But if you know how to plot your y-intercept and plot your slope, then this lesson is just going to take it one step further. Let's try some examples on the next little part. So example number 1 here, we have the equation, or the inequality, y is less than or equal to 2x plus 3. Is that in slope-intercept form? Yeah, y is by itself. So that's in slope-intercept form. I'm going to go ahead and identify my m and my b. My m, remember, is in front of the x, so my m is 2, or 2 over 1, because we like to deal with fractions. And my b is 3. So because I know that, I can go ahead and plot my y-intercept. And I could plot my first point. So using rise over run, I can go up 2 over 1. I could also go down 2 into the left one if I wanted to. There you go, I have a few points. Now let's look at what kind of line we're supposed to have, though, and where the shading should be. And all of that depends on that symbol right there. So let's refer back. When I had a less than or equal to, I can just refer back. Where is that in my little chart? I'm highlighting them for you. Oh, I think it's my second one. Less than or equal to, that tells me it's going to be a solid line and shading below. So I can go ahead here and say my line will be solid, and I will shade below. So since my line's solid, I'm just gonna draw that lovely line, and then I'm gonna shade below. Example number 2 is a little bit trickier. It's negative 5x minus 2y is less than 8. Is that in slope-intercept form? It's not. So we need to change that into slope-intercept form before we can do anything. So remember, getting in slope-intercept form is getting this y by itself. So I'm going to move this negative 5x by adding 5x to both sides, which leaves me with negative 2y is less than 5x plus 8. Now I just need to divide by that negative 2. And maybe you remember from the beginning of the year what happens when you divide by a negative number with inequalities. If you don't, pay attention. If you divide by a negative number, you need to flip your symbol, which means that I'm going to have y is greater than negative 5 halves x minus 4. Now it's in slope-intercept form, and we can identify the m, which is negative 5 halves, the b, which is negative 4, and then I can go ahead and use that symbol and use my chart to determine that I need y is greater than, it's going to be a dashed and above line. So as you can see, I plotted my y-intercepts, my slope, I made my dashed line, and I'm going to shade now above. All right, something we missed on the first one, but I kind of wanted to just wait until we had 2 examples, is looking at the question that is asked. Because we're not just asked to graph the line, but we're asked to find if a point is in the solution. So let's take a look at example number 2, and then we'll go back to example number 1. The very bottom in that dashed box, it says, is the point 2, 2 in the solution set? Yes or no? So all we need to do is plot that point 2, 2 and see if it's in the shaded region. So 2, 2's right there. Is that in the shaded region? Yes. Then it's in the solution set. Yes, it is. Right? If it wasn't in the shaded region, then it wouldn't be in the solution set. It wouldn't be a solution to that inequality. Going back to example number 1, it says, is the point -3, 2 in the solution set? So again, all we need to do is plot that point. So I've plotted that point 3, 2, or -3, 2. Is that in the solution set? Is that in the shaded region? It's not. So it's not a solution. These next 2 examples are a little bit of weird problems you might notice here, because there are examples of what happens when we have a vertical and horizontal line. So let's take a look at those. We're going to kind of look at those a little bit together. If you remember from your Mr. Slopeman face way back when, or maybe just remember, if you have y equals anything, that's going to be a horizontal line at whatever that value is. So y is greater than or equal to -4 means that my y-intercept is going to be at -4, and I have a slope of 0. It's going to be a horizontal line where y is -4. But we need to take a look at what kind of inequality symbol, what that's going to mean for the type of shading and boundary line. So using that chart, it's greater than or equal to, that line is going to be solid and it's going to be shaded above. So graphing that line, it's just a horizontal line right there, it's solid. But what does above look like? Well, it's what you would think. It's just above. Anywhere above. So when answering that question at the bottom, it's a horizontal line. And is that point 3, -4 in the solution set? Well, is 3, -4 in the shaded region? It's on the line. Is that line solid? Yeah? Then it's in the solution set. If that line had been dashed, it would not have been in the solution set. But because that line is solid, it's a part of the solution. So that's an important note to make. If it's on the line and the line's solid, that point is included in the solution set. But if it's on the line and it's dashed, it's not included. Let's take a look at example number 4. X is less than 3. This is going to be your other type of line. It's going to be that vertical. So vertical one isn't going to have a y-intercept, and it's not going to have a slope. It's going to be undefined. But it is going to be a vertical line wherever that x value is 3. So I put a point at x is 3. Now I just need to look at what type of line, because it's less than. That's going to tell me that I'm going to have a dashed line. It's not equal to. And the shading is going to be below, because x is less than. But what does below look like for a vertical line? It's just to the left. Okay, so for vertical lines, it's important to understand that below would mean to the left, but above would be to the right, because it's a little bit trickier to kind of just see where that shading should occur. And is that solution, or is that 0.33 in the solution? Again, we have a point that is on the line, but this line is dashed, so this is not going to be a solution. Okay, now use these notes as you get through some practice. Use your chart, right, to help you as you go. Ask your teacher if you have any questions, and good luck.